Hi there, and welcome to Let's Talk Farm to Fork, the PostHarvest podcast that interviews people of interest across the food supply chain. Today on our show, I'm joined by Steve Saunders from Robotics Plus, who I'll be talking to about how their autonomous food and ag robots are helping optimize fresh produce handling. So with no further delays, let's get started. Hi there, Steve. Thanks for joining us. How are you today?
I'm good, thanks. Just back from the USA and an exciting time with the Fera Robotics conference, which is all around agritech automation.
Oh, that's fantastic. Well, thank you for your time. Before we get into it, though, would you mind sharing a little bit about yourself and what you do, and maybe a fun fact about yourself?
Yeah, sure. Look, I'm 36 years, actually a grower. So I left school when I was 17 and really started a career in horticulture and worked my way through most aspects from nursery through to running orchards, through to post-harvest operations, packhouse cool stores, and did that in a very short time frame before actually heading out and starting a string of successful horticultural companies over the last probably 20 years. So yeah, just a real passion for growing. I think one of the things for me really that inspired me around creating companies was the opportunity I had when I actually was working for someone, sort of been involved in extension. So particularly out of the old math tech days in New Zealand, where new products and kiwi fruit like artificial pollination, high cane, those sorts of things. I was actually one of the first people in the industry to be an extension user of those technologies. And that really opened my eyes to how you can adapt new things to do things better within the orchards. Yeah, so I've just had a great career and a great passion, from owning a number of horticulture companies, from the largest orchard management company in New Zealand. We were running 150 kiwi fruit farms, to starting the world's largest kiwi fruit pollination company. So extracting pollen from male flowers and then reapplying it to set better fruit, to, being one of the founders of Mount Packencool, which is now the largest privately owned kiwi fruit packhouse that packs over 24 million trays of gold kiwi fruit. And I was also one of the integral investors right at the very start of Rocket Apple, which is now a successful proprietary variety apple grown all around the world and making waves. And then I also did work around supporting Māori horticulture as well. So I was one of the instigators for Meadow, which is a collective of over 27 Māori entities invested into growing blueberries. So yeah, lots of time in horticulture, but through all of that, I guess, I developed this passion for how technology is going to play a role in our future sustainability. And fun fact for me is, I think is 2007, I crossed the Gobi Desert on a blow cart, which is a startup that was based here in Tauranga, where I live. So that's like a land yacht, and went from one side of the Gobi Desert to the other. So that was probably one of those real life-changing things for me, is that going out and putting myself in a challenge like that really opened my eyes to a lot of things. So,
Is that one of those land kite surfing type devices? Am I thinking of the right thing?
yeah, it's essentially you're on 3 wheelbarrow reels essentially, and a sail, and you're laying down in a pod. And so, we can reach speeds of 100 kilometers an hour on 3 wheelbarrow wheels.
Oh, wow.
So yeah, a lot of fun. And that was 12 people from around the world got together, and we did that. So it was a mixture of a few of us Kiwis, English, French, Spanish, and Dutch. So it was first people in the world to, I guess, land sail across the Gobi Desert. So that was pretty cool.
So awesome. I'd love to do that. But let's stay focused here. So you mentioned it a little bit before, but could you share us the inspiration behind the creation of Robotics Plus and the company's vision for the future of agriculture?
Yeah, look, Robotics Plus came about, I built Grow Plus, which was a large kiwi fruit orchard management company. We were probably the first large sort of independent management group that came in the kiwi fruit industry. And it was at a time of change when it didn't make sense to have full-time orchard managers on small orchards. So we sort of contracted that service back to growers, and that further built into supplying all the machinery, doing all the spraying, doing all the agronomy, supplying all the labor, and really growing top quality crops. And we can consistently produce better yields than the industry average as a management company. So, but during that time, when I grew up, it was all about plant management. But what I could see was this change where labor was even becoming challenging back in the early 2000s, and particularly around the 2008 onwards. Labor was
Mm.
becoming a challenge, and our management started becoming more about managing labor than actually managing the vines. So how could
Yeah.
we get the best out of labor
Mm.
to get a result? So, our orchard managers were becoming more about managing of people rather than managing of actual vines to some degree. So
Yeah.
I could see that pain point continuing at times, and particularly with the peak requirements of labor at certain times of the year. And I think that's one of the fundamentals is, I think if everything was smooth, labor would be no problem. But in horticulture, we have these peaks where we need a lot of labor for short periods of time, and that's really hard to manage.
Mm.
So I got sort of interested in what was happening in robotics and automation, and went looking around the New Zealand universities. And I think that was about in 2008. I found Alistair Scarf, who's a co-founder of Robotics Plus. I found him at Massey University, and he had just finished a degree in mechatronics with first class honours, and sort of spoke with him, and he wanted to do a PhD in industrial automation. So I supported him in that PhD, and we did that project on, could we harvest kiwi fruit robotically? And quietly behind the scenes, I said to him, if you can prove to me that we could pick a kiwi fruit on an autonomous platform in an orchard, we'll start a global robotics company, and we'll really go and solve some of these complex, challenging problems. So that was
Yeah.
really the foundation of it. So Alistair did his PhD and completed that in around 2013. So Robotics Plus really started more around the 2013, 2014 mark, not 2008. I registered the company, but it was really about supporting Alistair in his PhD.
Sure.
And I had a few other robotic projects going on with some other people I'd met around as well, which is where the genesis for the Aporo apple packer stemmed from.
Yeah. Okay. Well, on that note, can you tell us about the Aporo fruit packer and how it revolutionizes the fruit packing industry?
I'll just expand one little bit on the vision for
Yeah.
our robotics and automation. And really for us, that is, our vision there is really about replacing those repetitive, dull, dangerous, dirty jobs. So there's a lot of automation already, but for us, it's that last point of where labor stands, where it's probably more complex, where you're out in an environment like an orchard. So if you can imagine, industrial robotics in a warehouse, stacking boxes or cartons, or even automated car building factories, parts come to a robot does a task, and it goes to the next robot. But when you go into horticulture, you're actually going out into complex environments where you've got poles, structures, you've got trees that grow in different shapes, you've got fruit that hang in different positions, you've got weather, you've got mud, you've got terrain, you've got so many complex challenges that you have to solve. So that's has always been a big focus for us, is taking automation into the field. We see that as one of the most complex, challenging areas. But we
Yeah.
also built things like the Aporo to demonstrate how technology can work. And the focus of the Aporo fruit packer was really about where you had people standing on a hard concrete floor all day at the end of a packing line, just putting apples and rotating apples with the best color side up, and orientating the stem and calyxes to look, presentable in the tray. And that's
Yeah.
really hard work, standing there 8 to 10 hours a day, standing on a rubber
Mm.
mat on a concrete floor, and that's all you're doing. It's very repetitive. It's very mundane in terms of job satisfaction. And it wasn't about replacing jobs either. It was, most pack houses struggled to get the labor to fill those positions. So,
Yeah.
have been a pack house owner, I know what it's like. We could have 200 people on our books to get 100 people turn up on a given day, if that makes sense. So for us was really tackling that really mundane stuff and creating better jobs for people within the pack house, like more quality control and other things. So that technology was about really at the end of the grader. So you might have had the grader systems that sorted the fruit and sent the fruit down lanes and dropped them into packing lines at the very end where people stood and did the last thing. So our focus there was to replace that job. So the Oporto goes at the end of the line where the fruit comes off the grader, and using cameras and artificial intelligence and robotics, we're able to stem and calyx orientate the fruit, pick that fruit up, rotate it to whatever degree angle you want the stem and the calyx to face, and put the best color side up for presentation. And being able to do that at the speed of humans or faster and consistently day in, day out. So that was really the genesis for Porto. So where you might have had 2 to 3 labor units, we could get that down to 1 labor unit. So, making a significant saving to the pack house in terms of labor requirement in that piece of the operation.
Well, that's brilliant. To take the conversation in a different direction, though, can you tell us a little bit about the unmanned ground vehicle and what tasks the UGV can perform to enhance productivity and reduce manual labor in farming operations?
Yeah, sure. Our UGV, which is, by the way, is now named Prosper.
Oh, great. Prosper. I love that name.
Yeah, we've given it a name because unmanned ground vehicle wasn't very sexy, but so we've sort of named it Prosper, which is, really about it being a machine that offers prosperity to our farmers and the opportunity, it's really the opportunity to prosper, I guess, is why we came up with that name. But essentially, when we did Aporo, that was about our first project that for us tested that we could build a robotic machine that had a great return on investment for the customer. It was solving a real problem. We designed it, and then we were able to, productionize it and take it to the world. And we've got machines in countries all over the world now, all running really, really well. And then we also have done some smart machines around port automation, particularly in the forestry industry. And that was another one that we work with the customer to solve a specific problem. And, we've now got these robotic scalers on most of the ports in New Zealand. But our long-term goal has always been around our autonomous vehicle in the field. And with the focus of building a truly multi-use autonomous vehicle, and by autonomous, it means that this machine does not have a seat, a steering wheel. It's fully autonomous. We fly a drone over the orchard once. We map the orchard. We can load that into our software system, and we can plan tasks on that map, like which blocks we want it to spray, or in the future, do a number of other tasks. So the idea of this vehicle is, it's getting people out of the dirty, dangerous environments, getting them out of the spray environment where one operator could operate a number of these machines by monitoring on the edges of the orchard as opposed to being in amongst the spray, if that makes sense. And then it was also about creating smart technology on the sprayer as well. So our vehicle is a fully electric vehicle, but powered by a diesel generator, essentially a 74 horsepower diesel engine that drives a power generator. So we get the benefit of full electric, and we get significant reductions in fuel consumption. So we're estimating, for doing the same task, around 70% savings in fuel. So we're really working towards that sustainable goal, that carbon zero. The reason we're going hybrid is battery technology at the moment, in our view, is not good enough to run long operational hours when you're putting it under load. So for us, the hybrid system was a more practical approach from an operational perspective. And later on, when battery technology gets good enough, the vehicle's already electric. We can just take the engine block out and put a big battery in there. Or if biofuels, for example, do become more common, like hydrogen or biofuels from forestry or whatever, wherever they might come from, we kick the diesel engine into a biofuel machine. So we sort of took a middle of the road approach in terms of the way we power it, but everything on that vehicle is full electric. There is not a grease nipple on that machine. There is not a hydraulic hose on that machine. Even the sprayer is electrified, and all the tools we're working on, like weeders and different things for vineyards and apple orchards, will all be electric, so that we're just really getting rid of oils and those sort of fossil fuel things. Then if you think about the proposition, there also is, we're minimizing maintenance. There's no greasing. There's no hydraulic hose leaks to fix. very simple 74 horsepower diesel engine service. Everything else is in a modular basis. The electric drive systems are sealed for life. So, if there's a fault with one of those, you just replace the electric drive system. The compute brain on the machine is a module. So if there's a problem there, you just unplug it, unbolt it, slap another one in, boot it up, and off you go. So we've really focused, coming from being a grower, really focused on super ease around keeping the operational uptime at the highest level. That's really important to farmers.
So then what are some of the challenges that the team at Robotics Plus has had to face when developing your technology?
Yeah, it's a good one. Challenges generally, as I described earlier, is a lot of the different configurations of orchards, the shapes of
Yeah.
orchards, row widths, posts, growing structures. So, it's really challenging as an ag tech company as to what are you trying to solve the problem for? You trying to solve the problem for a 3D growing apple tree, or a 2D growing apple tree, or a V trellis, or a wall fruit, or a freestanding tree. We had to do a lot of work to say, where is the trend heading? And, what we're seeing globally is more and more apples are becoming, apple growing, for example, is becoming more structured in the way they grow. I think a lot of the big companies now are growing for automation because, automation's not something that's going to fix an inefficient system or a bad problem. Automation is something that can enhance a good system. So there's this need around, growers need to sort of think about how they transform and grow for automation as well. So luckily in the apple industry, a lot of growers are creating 2D grow and trellis systems. It really opens the door for robotic harvesting, more precision farming from scanning, more precision farming from spraying. So, we've sort of gone down the track of really working towards the more modern growing systems because we see that as the future, and then being able to build our robotic systems to sort of support those future growing systems as opposed to some of the older growing systems of the past. And then we have things like slopes, muds, things you learn like, America has gophers and they make holes in the ground, and you got different rocky soils and sandy soils and muddy soils, and then you get the wettest year on record. So it's really been a lot about time in the field and really learning about these different environments and being able to tune the machine. And the great thing about our autonomous vehicle, mechanically, it's fantastic. It's like all-wheel drive. It's like permanent diff lock on all wheels, so it's like a
Yeah.
modern European car where each wheel's got its own drive and sense. So these things are quite incredible in terms of their torque and their ability to work between the different wheels to get out of different situations. Probably much better than sort of tractors in some respect. And so mechanically, we've built a really solid machine. Where the magic is really around the software. It's really a software platform now, which allows you this ability to continue to fine tune the machine. So, if we find a new row structure or some new obstacles we haven't seen before, that's just about spending a bit of time with the sensors and the software to just work out how do you work around that. So we can build these wins quite quickly. So
Yeah.
what's been important to us has just been, having a really great software team and having a really good computing system and sensing system on board the vehicle. And that's also
Yeah.
important for machine safety as well. Obviously you don't have a driver on these things now. So, you've got a real responsibility around object detection and avoidance and safety systems on these things as well.
Yeah. I'd imagine the safety systems around robotics is a bit of a dicey scenario to navigate. So then, taking a step away from the solutions that Robotics Plus is providing to the industry, what in your opinion represents one of the main challenges or pain points in the fight against food loss and waste?
I think it's a really good question. Food waste for me can be on orchard, but it can also be a lot in the supply chain. So I think the way we approach it is optimizing the quality of the fruit on the tree, which minimizes waste from an orchard perspective, and being able to dial in more consistent crops for growers and more timely applications of things to protect the fruit to give a better outcome. I think that's, for us, is where a lot more of the big impact is. I think, once you go into cool store and supply chain, that's a whole different, and I think that's where a lot of food waste sort of occurs more from after it's been picked and put into the cool store, that supply chain. But I'd probably turn it around and say the challenge at the moment, the way I see for farmers, is people can't afford to pay a lot more for this fruit. Buying fruit and veggies for most families is expensive now,
Mm.
and the cost of producing food is rising dramatically. Farmers are really, really struggling. If you think about places like America, the big scaled operations, and they run on making small margin on large scale, and pressure on cost is becoming really, really hard for growers. If you think about the California laws where they're having to pay time and a half after 40 hours, and I think that reduces down to 38 and a half hours. The same laws are happening in Washington. You're seeing minimum wages rising here. You're seeing New Zealand farmers struggling to get labour. You're seeing Australian farmers paying well over $30 an hour for labour. So there's this huge cost pressure on growers. So, really our vision and what we're trying to do is, how can we reduce that cost pressure? One thing about a robot, once you solve a problem where it can spray, it's a fixed cost as opposed to labor, which can continually be going up. For us, it's about trying, how can we help fix some of those pain points to allow growers to remain sustainable, be able to bank on fixing that cost at that point in the supply chain. So that's where the real drive is going, particularly from the growing side, is really about, it's that pressure on costs, resource, labor. It's really challenging, and a lot of the people can't find the labor either. So that makes it even harder, and that can drive things like crops not being picked on time or missing sprays, which then the crop deteriorates, and therefore they're only packing out 60% of the fruit they pick, for example, and that's your food waste, right? There's a 40% of what they grow doesn't go to a consumer because it doesn't look good enough or doesn't meet the standards for a retailer. So if we can optimize those pack outs, we can minimize those labor risks, we can fix those costs. That's where we really see automation playing a big role. And I think we're just on the brim of adoption of these technologies now. It's being an ag tech provider is a hard space. Grower adoption's a challenging thing because growers have done things the same way for a long time, and you're coming along with some new thing that drives along without a driver.
Yeah.
It's quite a new thing to think, and it's also, you've got to change the way you operate. There's things you have to change in your systems about the way you grow. But what we're seeing is we're starting to see the adoption of these technologies starting to move. I think we're really at the start of a exciting evolution in growing, where I think these technologies are advancing. Technology in general is advancing, and it's allowing this ag technology to advance more to a point where we're starting to see adoption starting to happen in that field.
Yeah, I agree. I feel like the technology is advancing so much that the industry is really looking to rejig and reshape the way that processes are done, and mass adoption really is taking place. So that's really cool. So as we come to a close, Steve, I just wanted to ask you, what is the major point you really want the listeners to take away from this episode?
Yeah, that's a good question. I'm a passionate grower, so I guess for me is, growing these fresh food for people is actually really challenging. And I think people understanding how hard it is to actually produce that food, that's not the farmer that's necessarily putting the pricing of food on people. There's retailers take a fairly good margin in the growing systems. But I think the message for us is that growers are actually really passionate about supplying food for people. It's really, really challenging for growers to do that in the current environments. And the pressures coming from minimum wage and wage increases, and there's a lot of people just don't like doing these jobs anymore. So people want to go to the cities. They want to be podcasters or website developers, or even greater inspirational things. So I think the big message is that the support and adoption of ag technologies, I think, is really, really crucial if we're going to want to enjoy fresh fruits and vegetables in the future, because Yeah, people just don't want to do that dull, dirty, dangerous work. They have better aspirations, I should say, that and what they want to do. And I just think in general, being an ag tech company is a really tough space. It's not hugely scalable like selling iPhones. It's quite crop specific, and it takes time to build adoption and takes time to build scale. So I just think all across, we need to support farmers. We need governments and funds to support ag tech companies. I think at the end of the day, feeding people in the world is an important thing.
Absolutely. Couldn't have said it better myself. Well, that's all for today's episode of Let's Talk Farm to Fork. Thanks for listening, and thank you, Steve, for joining me today.
Thanks, my pleasure.
If you'd like to know more about Steve and Robotics Plus, check out the link in the description of this episode. Make sure to subscribe to the podcast so that you never miss an episode, and don't forget to leave a review and share with your friends. Until next time, you've been listening to Let's Talk Farm to Fork, a post-harvest podcast.